Okay, we'll be doing 33 next. I just wanted to say one last thing about this 1831. It turns out that the image distance was negative. That means it's a virtual image, and it means it's upright. So you can check that it's upright. Upright means that the magnification is positive, and it turns out that it is. It is. So any upright image is a virtual image. They always go together. Upright and virtual mean the same thing. This was a let's see, this was a lens, converging lens. So a converging lens is a little more difficult sometimes than a diverging lens. The reason is a converging lens, S prime, could turn out to be positive or negative. For a diverging lens, S prime is always negative, so there's only that one situation. Okay, so I think the next one up here is 1833, which is a diverging lens. I'll leave the appropriate lens equations up here though. So 1833, and I'll read it. 33. A 2 centimeter tall object is 15 centimeters away. So 2 centimeters, that's how tall it is. And it's 15 centimeters in front of a diverging lens. And the focal length of a diverging lens is always negative. So minus 20 centimeters. So same deal. We want to find the image position and also S prime, the image position, and the image height. Good. So same thing with the lens equation. Solve this for S prime. This equation for S prime. 1 over S prime is equal to 1 over F minus 1 over S. So 1 over minus 20 centimeters minus 1 over 15 centimeters. Good. Perfect. So really, if you want, however you want to think about this, I mean, really it's minus 20 here, but you could write it like this if you wanted to. Put it right out in front. Minus 1 over 20 centimeters. That's the same exact thing. Minus 1 over 15 centimeters. Good. So let's do this. Let's finish it. Again, in your calculator, you could put it in right away if you wanted to figure out what this was. I see that there's a common denominator between these, so I'll just say that this is minus 15 over 300 centimeters minus 20 over 300 centimeters. Common denominator. So 15 and 20 turns out to be minus 35 over 300 centimeters. That's 1 over S prime. That's centimeters. So take this and invert it. S prime is 300 centimeters divided by 35. And don't forget the minus sign. So whatever that turned out to be, you'd put it in your calculator. And that's what S prime is. Now the way to get H prime is similar to what we did before. We'll use this top part here. Minus S prime over S is H prime over H. Multiply both sides by H. So minus S prime times H divided by S is H prime. So minus S prime, it's just going to be some number that you have here. I'll just write the whole thing out. So minus, I forgot the minus sign here. Well, here it is. So minus, then this is minus 300 centimeters divided by 35. That is S prime. And then times H, and H is 2 centimeters. And then the whole thing divided by S, and S was given to us 15 centimeters. I can write it here. Good. So we can see that this is going to turn out to be positive, and maybe the numbers will come out nicely enough that we could do it now. 40 divided by 35 or something like that. So whatever this turned out to be, 40 divided by 35 centimeters. And the minus sign went away. If I did the math right, I'm doing it in my head, so hopefully it's right. Okay. Good. So this is a diverging lens. With a diverging lens, S prime is always negative. That's the only thing that can happen. It always comes out to be negative. You can check that out by looking at this equation. When you solve for S prime, no matter what happens, S prime is going to come out negative because the focal length is always negative, S is always positive, so the image distance always turns out to be negative. And if the image distance is always negative from this, the magnification is always positive. That means the object, the image, is always upright and virtual. So upright and virtual always go together. And it always happens that way with the diverging lens. Great.